Get those numbers up. We got 13 in here, I think. 15, 13. I think it was 13, right? All right, what do you say? Let's get it going. I'm going to introduce, we're still, if you guys remember where we left off with our similar triangles before we started reviewing for the midterm, you guys set up these right here. 6 over 3 equals x over 4. This was called a what? These separately were ratios, right? But when I set them equal to each other, they were called a proportion. And if you guys remember here, there's two, when I cross multiply, anybody remember what these were called? These were the extremes, and these were called the means. So what I'm going to show you today is a special type of proportion, a special type called a mean proportional, where whatever's in place of the means, exactly the same number or variable. Okay? A mean proportion is when the means are the same values. Last time, a mean proportional is when I set up a proportion and the means are exactly the same and the extremes are different. So this first one here, find the mean proportional between 4 and 16. They tell me mean proportional. So where the means are, that's what they're trying to have me find. So I'm going to put x's there. They're the same value. And what are my extremes? The 4 and the 16 they provide. So there's my mean proportional. What number do I multiply by itself to get the product of the extremes? And I think we're okay here. X squared equals, I'm going to start right off the bat because I need to do a better job of this. X squared equals, here we go, 6. Is that Nate Dogg? One job. 10, 64. And now how do I get that squared out of there now? Little algebra work. 2, how do I get the squared out of there? Take the square root of both sides. Yep. So x equals 8, but that's only half credit. There is actually another number other than 8 that I can multiply and still get 64. I just took the square root. There's a hint, Spence. What's 4 times 4, though? 16, right? That's not going to give me 64, though. All right, Nate?
Positive and negative.
You got positive 8, but what happens if I put negative 8? What's negative 8 times negative 8? Positive 64. So when you take the square root, positive and negative version here. But as you guys know, we're going to be working with triangles. And can I have negative side lengths? No, I cannot have negative side lengths. So most likely what we're going to stick to is what's called the geometric mean. That's the positive value of what we just found. The positive value. So that's where we're going to stick. Forget the plus and minus. Just give me the positive value. Find the geometric mean between 15 and 20 now. So I see geometric mean. I'm going to set up my proportion. Means are the same. Extremes are given. 15 and 20. So x squared, when we cross multiply again, equals 8.
X 300.
300. Again, how do I get the squared out of there? 2 again. Take the square root. But notice my directions, though, on this one. Notice the directions. Simplest radical form, right? So I don't want that decimal, and maybe some of you are staring at your calculator. Come on, we have more than enough practice breaking down radicals. So I'm going to ask somebody in a second, what's the biggest perfect square that goes into 300? So when you get it, biggest perfect square that goes into 300? 9? Bigger. Bigger than 25. Because if I put 12 here, there's still a perfect square that goes into 12. So that's how I would know 25 is not the biggest one. Remember, 300. 300. $103. Good deal. So x equals positive 10 radical 3. I don't need to put the minus when I find the geometric mean, which is the means where we are going to find. All right, so everyone good? Geometric mean. Means are the same, extremes are different. All right, here's how I'm going to tie this into similar triangles. Let's get a diagram going here. A right triangle. So let's draw a right triangle out, everybody. With an altitude drawn from the right. What's an altitude do again? We just got off a midterm. If I'm going to draw an altitude from the right angle, what's an altitude do? Starts at a vertex and where? Yep. So from the right angle, I'm going to draw this segment, and it's going to be forming a right angle. All right. How many triangles are in my diagram? How many triangles did I just form up here now? 2 and the big one. So a total of 3. Everyone agrees? A total of 3? Here we go. I'm just going to call this one triangle 1, triangle 2, and triangle 3. And you guys are going to help me out finding a quick fact about them. So everyone, first thing, look at triangle 1, and we're going to compare that to the big one, triangle 3, and see if we can make a conclusion about the two. So that's all I want your focus on, triangle 1 and the big one. They both contain what type of angle? A right angle. Everyone agree. Triangle 1 and 3 both contain a right angle. And do they share an angle? The top one, right? So they have a right angle in common and they share an angle. What can we say about the two triangles then? Oh, why? By what method? Everyone, angle, angle? The right angles and the reflexive one. So triangle 1 is similar to triangle 3 by angle, angle. All right, let's keep going. Let's compare triangle 2 to the big one, triangle 3. Compare those. They both have what type of angle again? A right angle. And do they share an angle? Yeah, this bottom one right here. So again, by angle, angle, 2 and 3 are also similar. So 1 similar to 3 and so is 2. So what can we say about triangle 1 and triangle 2 then? They're also similar because they're both similar to 3. So we just showed what? All 3 of those triangles are similar to each other. All right? Take a step back. If they're all similar, what do we know about their sides then? What do we know about sides of similar triangles? They're in proportion, right? They're in proportion. Oh, boy. Oh. Imagine, don't write this down, but I'm like, all right, triangle 2, let's say that side's x. What does it match up with in the big triangle? I'll give you as much time as you need, but so that side I just marked x in triangle 2. Could you figure out what side it would match up with in triangle 3? Or triangle 1? If you're having a tough time, it's okay. If you're having a tough time, like this is tough for me too to visualize turning this triangle. What would that match up with so I can write a proportion? All right, I have a method for you. I have a little device, a couple devices for you to figure out how to match up these triangles so I can write a proportion. Here's the device. The first one is called Hills. HLLS. Okay? So this is how we're going to write our proportions in these diagrams. Hills. let's slowly talk about what each piece means. The H in hills stands for hypotenuse. Okay, that stands for hypotenuse. Where's the hypotenuse? Go back to our diagram, please. When we say hypotenuse, that's the hypotenuse of the large triangle. So let's make sure we label what we know as the hypotenuse. This is what we refer to as the hypotenuse, right there. The hypotenuse of the large right triangle. L, leg, leg. Leg of the big right triangle. So leg, leg. That's what we mean by the L in hills. Now, the next L, hey, the next L, also leg, but hey, same leg. What are the first two problems we went over today? When the means are the same. That's what we're doing here. That's what we're doing. The means are the same. The legs need to be the same leg, not different ones. The same leg. All right, the same leg. And the S stands for segment. What does that mean? When we drew our hypotenuse, when we drew our altitude to the hypotenuse, do you see how it broke it up into two pieces? Those are the segments. All right, right here. Segment, segment. But which one do I use? Right? Which one? Do I just 50-50 it? No, you're not. Which segment do you use? It's the one adjacent next to the leg you put in. Okay, so take a look. Let's say I use this leg right here. I'd use that segment length. Okay, you always pick the segment next to the leg in the proportion. Legs, both the same. Segment's the one next to the leg you're being used. All right? I'm not even going to ask if there's questions. We're going to hop right in, and you need practice before you become a little bit good and you can ask questions. Unfortunately, though, sometimes I'm not going to have enough information to use hills, but I still need to find the side length. So instead, the second and final device we're going to use, SAS. SAS. S-A-A-S. SAS. We're going to use this proportion if we don't have enough information to use hills. All right, what do you think the S still means? S? Segment. Now, do I use the same segment or different ones? Are these the means or the extremes in the proportion? Extremes. So guess what? They're going to be different. Darn right. These are both segments. Both different segments right here. Not the same, different, because you're putting them in for the extremes. And then finally, what's the A mean? It's the only piece of that diagram we haven't talked about yet. A stands for the altitude. All right, and this is the altitude that we drew in. Okay, that stands for altitude. And what do you think? Same or different? Same. I hope so. There's only one altitude in the diagram, right? You can't put two different altitudes down. There's only one in the diagram. Again, so whatever you put in for the means of hills or SAS has to be the same value. Last thing, these two here only work, hills and SAS only work if you have that type of diagram, which is a right triangle with a what drawn in? Well, I know it's a right triangle. That's why I have that. What did we draw in from here to here? It's got to be a right triangle with an altitude to the hypotenuse. That's the only time hills and SAS works. You can't use it on any diagram you want. It's got to be a right triangle with an altitude to the hypotenuse. All right, hey, what do you say? Let's do a little practice. We're going to do 2 on your own, and then you're doing those 6 on 2 together, and those 6 on your last 6 on your own. All right, here we go. Let's go to diagram 1. First, I want to make before we start doing hills, SAS, and getting nuts. Does everyone see a right triangle? Triangle ABC is a right triangle, and what's BD? That is an altitude to the hypotenuse. So this is the only type of diagram I can use hills and SAS on. Right triangle, altitude to the hypotenuse. Now the big question is, which one do you use? Right? Because you're only going to have enough information for one of the two. Here's the easiest way to figure it out. What is the altitude? Name the altitude in this diagram. Using letters here, name the altitude in my diagram, please. Name the altitude. 11. Where's the altitude in this diagram? BD. Is it labeled with a variable or a length? No, it's not, right? I know nothing about the altitude. Nothing. So which one of these two do I not even have enough information if I don't have the altitude? I can't use which one of these two? 1, and I don't know anything about the altitude, so I can't use. Everyone agree? I can't use SAS. That's how you figure out if it's hills or SAS. If the altitude is labeled, I use SAS. If it's not, I use hills. So here we go. Let's set up this proportion. Hills. And it's going to get uncomfortable at first. It's fine. We got 2 days of this. What's the H stand for in hills again? 5. What's the H stand for? Hypotenuse. That's the hypotenuse of the big right triangle. How long is it? So I can plug it in. The hypotenuse of triangle ABC is how long? 4?
12.
3 and 9. AC is the hypotenuse. We're all good. It's 12 units long. Leg. Now remember, you have 2 legs of a right triangle. You only have information about one of them, so you got to go with that one. All right, what are we putting in for the leg of triangle ABC that we know? 4 again?
Y.
Y, yeah. We don't know anything about BC, so don't touch it. Equals, remember the legs in hills are the same. They're always the same. And now S for segment. There's 2 of them, AD and DC. But I want the one next to the leg of Y I just used. So what's the segment next to leg Y? 5? 3. There you go. And there's our proportion that matches up the sides for us. 12 over Y equals Y over 3. Y squared equals 36. Take the square root of both sides. I don't need to worry about plus or minus here because it's a diagram. There's no, I can't put -6 in there. I can't have a negative side. So we're just going to have Y equals 6. Hills and SAS. Anything there you want to ask? Okay, let's go to the next one. Right triangle, altitude to the hypotenuse. Do I know anything about the altitude? 4. Do I know anything about the altitude? Is the altitude labeled?
As X.
Yeah. So it's labeled with either a variable or a length. S for segment. Give me a segment length. That's here. Segment length 10. 4. Altitude 7. X. Altitude again. X. Again, those always are going to be the same values. The means are always the same. Over. Remember, S is other segment. Extremes are different. Don't give me the same segment. Other segment length. 4. 12. Yep. And I'm sure you guys know how I want the answer left. little simplest radical form. Biggest one. 4 is not the biggest one. What'd you have when you get it? Biggest perfect square, 11 that went into 48, 16 and 3. So x will be 4 square root of 3 here. Okay, 4 square root of 3. Okay, you guys got the next 6 on your own. Take your time. If you want to talk with people within your group, that's fine. And then I'll give you about 10 minutes and we'll come back and see how we did. Okay? Decide if the altitude's involved. If it is, SAS. If it's not, hills. If it is a radical, leave your answer in simplest radical form. 6 problems, 6 people. All right, 6 problems, 6 different people here. And again, if you had a question on it, just ask. No big deal, because we're going to get a little tougher tomorrow. We're going to do it again. 10, let's roll. A, or yeah, letter A here. Proportion first.
4 over 6, and then 6 over x.
I like it. Cross multiplied, x equals
9.
9. Any issues? Had to use SAS there. Had to use SAS. All right, B. Let's roll 11. Proportion first.
10 over x equals x over 50.
X over,
50.
sure you want to use 50? 50 is the whole hypotenuse, right?
40.
40, right? You want to use 40 there, the 2 segments. Everyone's good? We end up with x squared equals 400, so x should have been equal to 20 there, 20. All good? Another SAS problem. You just didn't have the other segment, but you guys could subtract and get it. Good deal. C. 3. Proportion.
25 over x.
Okay, 25. Whole hypotenuse. Spence is using 21 and 4 over x. Leg equals
X over 4.
leg over. And then why did he choose 4 over 21? It's the one next to the leg we're using. Good deal. And then this one came out to be, what do you got, Spence? X equals?
100.
X squared equals 100.
X squared equals 100.
Right.
X equals 10.
X equals 10. Yes, great job. All right, let's keep moving. D now. D. 13. What's our proportion?
I didn't get this one.
Okay. Is the altitude being involved?
No.
No. So this is going to be a no altitude. I got to use hills. So looking at that diagram, the H stands for hypotenuse of the big right triangle. How long's the big hypotenuse of the big right triangle?
I wasn't sure if it was x or 12.
All right. Here's your right angle. The hypotenuse is always located across. So that's going to be 12. What's the L stand for?
The
Leg. And there's only one that's labeled in the leg of the big right triangle.
x.
X. Legs stay the same. And now S for segment next to the leg we're using. 9. I want to use 9 instead of 3. This should have been the only one, everyone, that you had to break down a radical. X squared equals 108. And that should have broken down, take a look, into 36 and 3. So X should have been equal to the 6 square root of 3 there. Okay. So we're using hills. All good? All right, let's move on. E. 12 already went. Oh, hi, Rachel. How are you? Okay, good talk. E, go ahead. What do you got?
I got 16 over x, and then x over 9.
Yep. Nice and easy SAS problem. Had all the values. X came out to be
12.
12. Yep. Square root of 144. And then finally, F. 4.
144 over x. And then x over 25.
Yep. Another nice SAS, easy SAS one. X came out to be,
60.
yep, square root of 3600. Okay. Any questions? Okay. 2 things. You're going to start working on the homework, which is pages 3 and 4. Tomorrow night, though, I'm giving you a heads up. We're back to the textbook. So whether it's online or your hard copy, make sure you got access to a textbook somehow tomorrow night, because we're going back to the textbook tomorrow night. All right, go ahead. You can get going on pages 3 and 4. Hills or SAS, remember, hills or SAS. If you have to round, there's some rounding directions as well. Might have to factor as well. Heads up, might have to factor tonight. If the altitude isn't involved, boom, automatic hills. anything, I'll be here.